Out of 1, April 13th. Alright, let's do this. Sum of leaves. Looks like just the sum of the leaves. Okay, so and I'm doing LeetCode. Thank you. Sum of leaves. Sum of leaves. I think we can do this. Ooh, no. There we go. If not root, right? If not root, or return 0, right? Actually, no, that's not right. Leaf, if root dot left, actually if not, I don't think so. I think Java is not like that. I think Java is equal to no, right? And root dot right equal to no. That's a leaf. Then we return root dot value, right? Otherwise, we will do left and right. And if root equal to no, actually, I think this one should be the first one, right? If root is equal to no, then we return 0. If it's leaf, we return this. Otherwise, we'll return sum of wait, hold on, left leaves? Oh no, it's left leaves. A leaf? No, there's no children. A left leaf is a leaf that is the left child of any. Oh my goodness. Oh, I thought it's just as simple as getting the leaves. Okay, so I need a little bit more. Right? A little bit more. So we should just return. Huh. How do you know it's a left leaf? Exactly, how do you know? Do we need to have another function? Because I need to know if the current is a left, right? I'm not sure how this one goes. Does Java have a Java has the default argument? Does it have it? Yeah, you have to override it. Screw this. Private int helper tree. Tree node. I can call it node, and the boolean value is left. Okay, if root equal to no, we'll return 0. That's the same. If is left and root dot left equal to no and root dot right equal to no, that's a left leaf. Not root, node. Ah, I guess that's fine. It's easier to change this, right? Otherwise, now we're just gonna go left. We'll return helper root.left and true plus helper root.right. This will be a false, right? Because we only consider the current one is the left or right. And this will just return helper root. What if it's... That's a good question. What if I have only one? Then I consider false. So it should be a false. It's not a left leaf. Okay, so let's try this. Cannot find symbol. Right. GHT. Alright, looks to be good. Let's try this. Oh, old problem. Done it before. Many times. I thought it was a new problem. I ran this for before. (2020) 2021. Long time ago. Yeah. Okay, so we're done with this. Okay, I want to move on. I want to first revisit this one. This is the collect rainwater. There's a 2 pointer solution. I remember 2 pointer. All right, let's just take a look. I forgot this one. We move towards the middle, the side that is smaller. And we keep track of the current marks on the left and right. Whenever height low is smaller than high, we're sure that there might be some rain trapped above height low, bounded by the mean height of left max. Someone can compute this. Okay, I don't quite understand. So we go left, right, moving towards the center. Okay, left and right, we're moving towards the center, and we keep track of the current max on the left, okay? Whenever height low is smaller than height high, we're sure that there might be some rain trapped above height low, bounded by the mean height of left and the right max. We can compute this. So, wait, what? Low smaller than high, left max smaller than right max. If height low is smaller than left max, then rest plus equal to left max minus height low. Otherwise, left max equal to height low. Oh no! Don't come on my leg, Jimbo. Okay, so I think what this means is we go through from left and right, okay? And at each point, we are going to count the amount of water above the height. I think this is what it means. So as we go through, like here we add this part. Here we add this part. Here we add this part, right? And we say we have left and a right. And as we go, whenever the left max is smaller than the right max, then anything on the left, if you are smaller, then you get collected. Yeah, because we have something on the right is higher, so the amount of water above you would definitely be collected. And if I have the other way around, then we go here. And how do we move forward? Well, if left max is smaller than right max, then we just keep moving forward. Right, we keep moving forward because every one of them gets collected, gets some rainwater collected. Once it's the other way around, I think I got it. Let's it's this one, right? Rain trap, yeah. So I'm gonna use 2 pointers. Go also keep track of the left max and the right max. When L max is smaller than R max, right? And if the height low is smaller than left max, then it is guaranteed that the amount of space above height low but below left max can be collected as rain. All right, we keep moving low to the right until left max is larger than right max. Equal works as well, so we probably get, okay, we're gonna do the equal here, right? Then we work on height high the same way. All right, rest is this. Then we can say int left max equal to 0, right max equal to 0. We have a low is 0, high is height dot length. That's not what we want. Wow, I didn't know you can do that. Height dot what? Height dot length -1, right? So while low smaller equal to high. Do we do smaller equal to high? Or do we do smaller than high? when they meet in the middle. Yeah, I think it should be smaller than high. I don't think we should meet in the middle. Okay, I'm gonna do D14. Okay. We say if left max is smaller than right max, smaller equal to right max. Okay. If height low is smaller than left max, then rest of plus equal to left max minus height low and lower plus plus. Oh, we can actually do this in one line. Let's do one on one line. Nope. Alright, else. Then we say left max shall equal to height low. Actually, I do think no matter what, low shall increase. Else, if height high smaller than right max, rest plus equal to right max minus height high, else right max equal to height high, and high minus minus. Keep going and do this. Okay, let's check how this one goes. Oh, this one seems to be correct. I mean, it does make sense, right? Basically, we guarantee that some water can be collected. All right, the second one is not right. So there's some issues here. Let's see, what issue is there? We're missing some. It's okay, let's check. So we have 4. 1, 2, 3, 4, 2, 0, 3, 2, and 5. Right. So to start, left max and right max is 0. Okay, and then yeah, I feel like maybe left max and right max shouldn't be 0 to start with. It's okay, right? So height low. Okay, so how about, no, we don't start with 0. What do we start with? Height 0. This is height dot length, and we can do it like this. Say int left max equal to height low, int right max equal to height high. Okay, we set it up. Does that make it better? Yep, I think that makes it better. And then to guaranteed, and whichever is higher, then we check on this side. Then as we go, every time you're smaller, you guarantee that the amount of water above you can be collected. If not, we basically set a new, yeah. Oh, that was bad. That was bad. Huh? It's not right. 5 5 1 7 1 1 5 2 7 6. So it's starting is here and here, right? Left hand 5 and 6. Now to start with, we don't have anything because left and high low is this is equal to. So now we move forward. Next one, still nothing. Now we move forward. Next one, yeah. So I should just mark with this, and then high is here. All right. So this we got 4. So plus 4. Right, and I move here. This is bigger, so left come here. Now this move here. So now I come here. Next we move here. So this is plus 6. Over here plus 6. Here plus 2. Move here plus 5. Then move here. That's nothing. So we have 10, 16, 28, 23. Yeah, it should be right, but this one is wrong. Okay, it's a programming issue. Right, L max smaller than this. There's one possibility that this one is wrong, but I want to make sure that that is a possibility. Well, I think I know. I think it should be smaller or equal to. Because here, when they're the same, right? When we go, hold on. So when we are at this, so we come here. Then high moving here. And then right max equal to this. And then these become the same again. Then left will move forward. But still, it is pointing to here, right? $18. Yeah, I'm missing this one. I'm missing this one. Yeesh. Because high moved to here. Then we come back in again. Now R max equal to this. Now high move to this. Oh yeah. It should be smaller equal to. Just because the way it's set up. And this is faster. Because we don't have to deal with a stack. No need to deal with stack. Still took some effort. Okay, so that one is good. trapping rainwater. All right, find the longest equal subarray. You're given a zero-indexed integer array, nums, and integer k. A subarray is called equal if all of its elements are equal. Note that the empty subarray is an equal subarray. Return the length. The length of what? Longest possible equal subarray after deleting most k elements. So an equal subarray, if all of its elements are equal, okay, the length of the longest possible equal subarray after deleting most k elements. It can be any elements, right? It can be any elements. So if we do this 1, 3, 2, 3, 1, 3, right? So k is equal to 3. Can delete most 3. And after deleting, we want to find the longest possible. I mean, because it's a subarray, so we cannot reorder, right? And we can look for, so we know 1 occurs 2 times, 2 occurs 1 time, 3 occurs 3 times. So we can say, okay, our hope is to see if we can get 3. So we find 3, and among that we have a length, right? And then we have 2 of them, so that's good. So it's becomes 3. So basically what we're gonna do is we'll go through the entire thing. So 1, we can get a list of, you know, things out of it. 2, get a list of things, indices. 3, get a list of indices. Okay, and we can, you know, check. How do we check, right? How do we check? Well, we go for the one with the most repeats, right? And with the most repeat, actually we can just go through every single one. For each one, we try to see the maximum we can get out of it. How do we see the maximum we can get out of it? So this is gonna be, you know, I1, I2 to IP, can call IP, right? And this is just, it's not consecutive numbers. And what we want to find is what is the window such that the gap is not longer than k, right? The gap is not longer than k. So I can see, okay, this is what we have, and then we move on to this. Yeah, so it's like a sliding window, right? For each one we do a sliding window. For each one we do a sliding window such that the difference between the two, yeah, so this minus 1 is the number of elements in between, is smaller or equal to k, right? It's smaller or equal to k. Smaller or equal to k. And if it's good, we just keep extending until we cannot extend. And then, so we keep extending until we cannot, right? Then we record its length, then we remove the front, right? We move this forward, and then we try extending as much as we can. We check, we remove the front, and then that way we can get a maximum. So it's a sliding window for every single one, and at the end we try to find a maximum. Okay, let's get this one. Hopefully we can do this fast. 31, yes. Okay, so what we're gonna do, we need a collections, no, default dict. Yeah, we need default dict on this one. So we can say indices. Bless you. A list. Oh no, this right. For I n in enumerate nums indices n dot append I. Okay. Then we say res equal to 0. We'll find the length. Yeah. And then we say for indices. What should I say for lists in indices dot values. Okay. Right, for each one. And then we're gonna do sliding window. So we can say low high equal to 0 and 0. Right, low and high, 0 and 0. And let's not do low high. Let's do I and j. Ugh. Let's do I and j. Okay, so I and j equal to this, right? And what do? Actually, no. We need to keep one of them. Okay, and we say for j in range. So j will always just keep going, right? J always keep going, and j will keep going starting from the. Oh, can go from the second one. Right, we can go from the second one. So we can say go j range 1 towards list line list. Right? Is that right? No, I think it should just be just do this. Right? So we extend and then we check. Right, we check. And we say if indices, now list j minus so the amount in between the two, right? Yeah, the amount between the two minus list I minus 1 is smaller or equal to k, then res equal to maximum res. Beautiful. Res j minus I plus 1. That's the total amount, right? That's that right? Yes, that's the total amount that we can produce. Yeah. So it'll be like that. If that's the case, right, we do it. And if not, right, so we extend here, we check, then we go to the next one, we check, next one, we check. But if we hit something that is not, right, just it's too much, right, then we have to remove then I plus equal 1, right? So we extend j, but now the range is too big, right? Now the range is too big. Then if it's too big, we remove this going for here, right? And then we go, okay, so like we do that until we hit the end, then we have this, and then we'll return the rest. Okay, let's try this. I'll run these two and see if it works. Does it work? The second one doesn't work. Huh. Well, I think it doesn't work because we didn't check at the end. We need to check at the end. So as we go, once we hit the end, we have the j, and the rest are equal to maximum. Rest is j minus I plus 1. because this if condition might never hit, so at the end you have to hit it one more time. In this case, I think it will be better if we just put them outside, right? I think we can put them outside. So while j is smaller than len list, right, we do this, and every time we say j plus equal 1, and then at the end we do that. Okay, let's go back. Try it again. Okay, I still didn't get it right. That is interesting. Huh. How is that? How is that even possible? Well, for one thing, I think at the end it shouldn't be this way. I think at the end we shouldn't do it. It should be like this, but I think it's still going to be wrong because j at the end will go outside. Then my output is still 2. That is bizarre. Very bizarre. Yeah, this actually should be... You know what? I think the original... I think the original is right. It's just... Okay, list j, like... List j minus list I. So I is always start with 0, right? And this is good, and this... Oh, smaller equal to k should be the... Nah, that was the total number of... Yeah, that is not right. It shall be the total number. My bad. It should be this is the total number minus, right? This is from j to I, right? So list j to list I. This is the total number of elements in the subarray. Now we need to minus the number of in here, which is minus j minus j minus I plus 1. Right? This is, we should say find the number of values to remove. Right? And we can simplify this by minus j plus 1 is smaller equal to k. Then we're gonna add j minus I plus 1. Yes, I think this most likely is correct. Yes. All right, let's submit this. Maybe I should do this one. Use sliding window on the indices, on the array of indices for each number in the array. 走你! Hey, no, I pressed the wrong button. All right, let's go. Come on. That is good. That is good. Okay, that will be it for today. We finished this with a 94% performance. Oh, see you guys tomorrow. Adios.